So today we're gonna see the part 2 of sets. So today properties of sets. First operations. Operations we have union, intersection, difference and complement. Union means we adding of both, like in set A and set B will be together known as A union B, and the A intersection B means common point of A and B. For example, A is equal to 1 comma 2 comma 3, A is equal to, and B is equal to 1 comma 2 comma 4, and the A intersection B will be 1 comma 2. The common element is 1 comma 2, so that is intersection. A minus B is a difference. A minus B means the set of B should be subtracted from the set of A, that represents A minus B, and the complement is A dash. If for example an universal set and an A set A is there, means for example universal set is equal to natural number, which is I'm writing 1 comma 2 comma 3 comma 4, and it goes on, and A is equal to 1 comma 3 comma 5, and it goes on, such that A dash will be 2 comma 4 comma 6. It will not be in the A, but it will be in the universal set, that is complement of A. Then we are going to see the properties of union. The properties of union is commutative law, associative law, identity law, idempotent law and law of universal set. So first, A union B is equal to B union A, which is rearranged or reordered. That is called commutative law. Then A union B, the whole bracket, U union C. First we are doing A union B, then the union of C is equal to A union, the whole bracket, B union C. This is called associative law. So in this first we are doing B union C, then with that we are doing A union. So A union phi, which is a null set, is equal to A, where this null set B as an identity. This is called identity law. Whatever is represented here will be the final answer in identity law. Then A union A is equal to A. This is called idempotent law. For in a set, we know that the element will not repeat in a set, such that A union A will be A. Then universal law, that is universal set union universal set will be the U. As I already told that the element will not repeat in a set, such that that is law of universal set. Then we are going to see the properties of intersection. Whatever we saw in this union will be straight away for the intersection, which is a common point of it. So A intersection B is equal to B intersection A, which is commutative law, as we already saw in that. Then A intersection B, the whole intersection C is equal to A intersection B intersection C. This is associative law. Then phi intersection A is equal to phi, because in this we have already seen that A union phi is equal to A in identity law, but here phi intersection A will be null set, because there is no common point between the null set and A, such that this is called law of null set. Then union intersection A will be A, because an universal set is a collection of every basic set. So from that if we take A, the common point will be A only. So such that that is law of universal set. A intersection A is equal to idempotent law, as we already saw there. Then A intersection B union C, which is equal to A intersection B union of A intersection C. This is called distributive law. We are distributing the properties. Then we are going to see the properties of complement set. For a complement set, first we have 4 different types. One is complement law, another is De Morgan's law, another is double complementation, and law of universal set and null set. So first, if you add like A union A dash, which is equal to universal set, because the A and A dash belongs to a universal set. When we add both of them, it will become as universal set, as we already saw an example here. That is called complement law. Then A union B the whole dash is equal to A dash intersection B dash. And another example of another formula is A intersection B the whole dash is equal to A union B, A dash union B dash. This is called De Morgan's law. The third one is A dash the complement of A, that is the double complementation. For example, A dash is equal to 2 comma 4 comma 6. We have already given an example. The whole dash, that is complementation of this A dash is again will become as A, that only represented as double complementation here. Then null set, that is phi dash, is equal to universal set. This is called law of phi null set. And this is universal dash is equal to null set. This is called law of universal set for complementation. And we have some for general terms for identifying the number of terms in A union B. So n represents number of and A union B. So number of A union B is equal to n of A plus n of B. So if we add both, we get the number of elements in that. Then A intersection B is not equal to null set if it is a condition here. So if A intersection B is not equal to null set, then the formula will be n of number of A union B is equal to n of A plus n of B minus n of A intersection B. This is our general terms of the formulas. That's it.
Very good.